I am Christophe Letourneau. I am a medical oncologist working at the Institut Curie in Paris. I am the head of the phase 1 program and also of the precision medicine program there. I'm also doing head and neck oncology. Yeah, the SHIFA trial is a clinical trial. It's a clinical trial for patients with any kind of cancer that is refractory to standard of care. And the goal of this clinical trial is to compare the efficacy of targeted therapy based on the molecular alteration we have identified compared to usual chemotherapy we use in this patient in the routine. So this clinical trial has started in October 2012 and we have finished accrual, in fact, in May 2014, and we have included 740 patients. 170 patients have been randomized to date, and we plan to randomize 200 patients in total. You're right, this kind of clinical trials is expensive because the technologies, even though the costs have decreased dramatically, are still a little bit expensive. So we are looking at mutations and gene copy number alterations in the trial, and also we need to provide the drugs. So it's a high amount of money. So we succeed in getting some national grants for this, and especially for the techniques and technology, but also we got funding from donors. So the Institut Curie is a foundation, and through that way we could find money to run the trial. So without all the donors, we couldn't run the trial. The thing is that people in real life and doctors are all convinced that personalized medicine, so to analyze the tumor of the patient to guide therapy, is the way of the future. So that's probably why patients came spontaneously to us to participate in the clinical trial, but also other physicians send their patient to us, and this is why the accrual was so fast. So probably patients and physicians understand the concept of personalized medicine, although I must acknowledge it's much more complicated than what they think. For sure, it's very important to look at multiple molecular alterations. We know that patients with metastatic cancer, so probably will never be cured of their cancer. So if you know from the beginning of the cancer, all molecular alterations, it will be much easier for the physician to guide the patient towards specific targeted agents or clinical trials. But if you need to do that one biomarker by one biomarker, it will take tissue, and sometimes you will lack tissue, but also it will take a lot of time, and time for these patients is very important. The greatest advantage is that 40 patients in the trial, 40% of the patients in the trial have a druggable molecular alteration for which we have a drug to propose. And for the remaining 60% patients for which we haven't found any druggable molecular alteration for a drug within the trial, we could include some of these patients in phase 1 clinical trial with the matching drugs. So the big challenge was to set up the whole process, so because we had to get the tissue, to extract DNA, to send it to the platform, and then to centralize bioinformatics, and all this had to be performed within 4 weeks and within less than 4 weeks, which was the case. So the feasibility of this approach, which was published in the British Journal of Cancer this year, demonstrated that it is possible in the clinic, but you need to set up all this and to have someone that manages all the process for the tumor samples. Yeah, from a feasibility point of view, so we have shown that we can effectively use these tools in the clinic. So now we need to be sure that the results that we get are reliable and reproducible, so with a good sensitivity and specificity. That means that quality controls need to be performed during all the process, and this is very important for all these kind of clinical trials. So there are now several clinical trials like the Shiva trial running around the world, and probably the result of all these clinical trials will tell us whether in the future we should use these tools in routine. My point of view is that this will probably be the case. So it's always better to know more than less, and at least we can send patients to clinical trials, or maybe in the future we will prescribe targeted agents based on the biology and not based on tumor location and histology anymore. So. Yeah, translational research has made a lot of progresses, and this is why we have today many targeted agents that for subgroup of patients work remarkably good. So we have patients with metastatic disease living for several years now thanks to these drugs. The next step now is this kind of high throughput technology that allow to get the molecular profile of the tumor, and I think this is an accelerator for translational research. And my view is that this will be necessary in the future to have this for the patient before starting anything. My hope is that we'll be able to share all data. We are generating a lot of data, so each trial is generating data, and each team, what we need to do is to share the data so that we have more power to analyze the data, and an increased capacity to get results from this data, so that it translates into improved survival and cure for patients.